This lesson is a basic introduction to radians, so it explains what a radian is and how you can convert between radians and degrees. For more information on how you can use radians, you need to look at my next video. Radians is also known as the circular measure for angle because it is most useful when dealing with circles and circular motion. So we're going to start by thinking about radians by looking at a circle. So if we have two lines drawn from the centre of a circle, we know that we could measure the angle between them. If we call this angle theta, the Greek letter theta is often used to represent an angle, we know that we could measure that using a protractor and using degrees. However, there is another way of measuring angles, and it is often more useful, like I've said, particularly when dealing with circles, but also for things like differentiation and integration. The rules of differentiation and integration apply to radians but not degrees, so it is a very important unit of measure and something that you do need to know about, particularly if you are going to study higher maths. So as I've mentioned, we could measure this with a protractor in degrees, but another way of measuring it would be to measure the arc length around the edge of the circle in terms of the radius. So in this case, if we call the radius r, in this diagram, this arc length here is actually also equal to r. So we could say that this angle holds an arc length of 1 radius. Now this is only true because I have specifically chosen my angle to give me an arc length equal to the radius. If I instead had a smaller angle like this, then our arc length would have been quite substantially less than r. Or if I'd chosen a bigger angle like this, then our arc length would have been greater than r. So this is a special case, and I have specifically chosen the angle that gives me an arc length that is equal to the radius. If we have a look at a couple of other examples then, again, if this radius is called r, and this time we are measuring this whole angle and calling it theta, this time we have two radiuses or radii around the outside. So this angle here we could say has an arc length of 2 radii. This angle here, if we were to measure the whole way round, this angle would have an arc length all the way around the outside of 4 radiuses, so 4 radii. So you might be thinking this can't be that useful because it's only going to apply to a certain size circle. However, if we look at this circle where we had an angle that had an arc length of 2 radii, if we make the circle bigger, the radius gets bigger at the same time, at the same rate as the arc length gets bigger. So however big we make it, the angle stays the same. You can see there the angle isn't changing, but the arc length is always equal to 2 radii. So this means that this angle here is actually always equal to the angle that holds 2 radii, no matter how big the circle is. So hopefully you can see this isn't size dependent on the circle, it is independent of the size of the circle. Whatever size you make the circle, however big you draw it, this sized angle here will always hold an arc length of 2 radii. So you might be wondering where I'm going with this and how it relates to radians. Well, a radian is just the angle that holds an arc length or subtends an arc length equal to the radius. So in this case here, the arc length is the same length as the radius, so that would be 1 radian. So going back to our previous example, that would be 2 radians. This angle here would be 4 radians. And we could actually go all the way up to this one where we have 6 radians. So 6 radians, you can see, is a little bit less than a full circle. So in a full circle there are 6 and a bit radians. And you can see, for example, this angle here would be 5 radians. This one would be 3, and so on. So we normally use rad or rads or radians afterwards. So with degrees, 360 degrees, you obviously do a little floating 0 or degree symbol. For radians, if you wanted 2 radians, you would write that as rad or rads. There is the notation where you use a small r or even sometimes a small c for circular angle, but they can be very easily confused with the degree symbol, so it is more common that you put rads or rad afterwards. Let's think then about how big 1 radian is. So we've already said that we can fit 6 and a little bit radians in a full circle. Now if you know your equation or formula for the circumference of a circle, the circumference, which is the arc length the whole way around the circle, is actually equal to 2 pi r, which means that we actually have 2 pi lots of the radius, or 2 pi radii. 2 pi is equal to 6.28. Obviously, dot dot dot, it goes on, but to 3 significant figures it's equal to 6.28. That fits with our diagram over here because we have 6 and a bit radii in our circle, and that bit is actually equal to 0.28. So in total we have 6.28 radii in our circle, or 6.28 radians in our circle, and to be exact that is 2 pi. So in a full circle we can fit 2 pi radians. And to describe how big a radian is, I think it helps to go back to degrees, because degrees is something you've been working with for a long time and it's something that you can picture. So in a full circle we know that we have 360 degrees. So this whole circle is 360 degrees. So we need to split it into 6.28 or 2 pi parts, because each part is 1 radian. So to work out the size of 1 radian, we do 360 divided by 2 pi. That is actually equal to 57.3 degrees to 1 decimal place, or 3 significant figures. So each part of this circle, each segment or each radian, is actually equal to 57.3 degrees, which makes sense in terms of what you know about degrees, because if you picture an angle of 57.3 degrees, that one does make sense. So 1 radian is equal to 57.3 degrees, which is very important. And the other relationship we've established here is that 360 degrees is equivalent to 2 pi radians. So if you can remember this fact, so if you can remember that 360 degrees is 2 pi radians, or that there are 2 pi radians in a full circle, then you can work out how big 1 radian is, or how to convert any number of radians into degrees and vice versa. And to help you remember that there are 2 pi radians in a circle, it helps to remember that a radian is the angle that gives you an arc length equal to the radius, and because we know the circumference, which is equal to 2 pi lots of the radius, we know that we must be able to fit 2 pi of them, so 2 pi radians, in a complete circle, or in 360 degrees. So that is one reason why radians is more useful, because it is a direct link between the angle and the arc length or perimeter circumference of the circle. So obviously we've been looking at complete radians, but we're not always going to have complete radians. Sometimes we might have an angle that is roughly this size, that is obviously 1 and a bit radians. So we need to know how to convert between any number of radians and any number of degrees. So how do we convert from radians to degrees then? Remember, we know that 1 radian is equal to 57.3 degrees. Now this is not exact. That is rounded, so it is better to use 360 over 2 pi. That is where our 57.3 degrees came from, because we split the full circle 360 degrees into our 2 pi radians. That does simplify down to 180 over pi by dividing top and bottom by 2. So you could use either of those as 1 radian. They give the same answer. I find that the 360 degrees over 2 pi is the easier one to remember, because it relates more to a full circle, but 180 over pi is equally as valid and actually more simple. So how do we convert 4.2 radians? Let's think exactly what we mean by 4.2 radians. So remember, each one of these is 1 radian, because it's the length of 1 radius around the outside. So if we've got 4.2, 1, 2, 3, 4 and a bit. So it is quite a large angle, somewhere between 180 and 270. So it's good at this point to estimate first, to have a think first how big you are expecting it to be, remembering that there are slightly more than 6 in a full circle, so 4.2 is definitely more than half. So each radian is 360 over 2 pi, or 57.3, but that's rounded, so we're going to use the exact value. And we've got 4.2 of them, so we're going to multiply that by 4.2. That gives us 241 degrees to 3 significant figures. And again, a sense check tells us that that is roughly correct, because it is somewhere between 180 and 270, so that looks about right. If you had done it the wrong way round, which is the most common mistake, a lot of people get the fraction the wrong way up and they would do 2 pi over 360 times 4.2. That would actually give us a very, very small answer, 0 point something. So we know immediately that that is wrong, because 4.2 radians is going to be a very large angle. Pi by 2 radians then. Often you will see radians given in terms of pi, because there are 2 pi of them in a circle, so it keeps it more accurate. So if we think about our circle in terms of 2 pi radians, we know that exactly half of the circle is going to be pi radians, because we've got 2 pi in total, so half of it, or 180 degrees, is equal to pi. That means then that half of pi, is actually equivalent to 90 degrees. So without even putting this into our calculator, we do know that that is 90 degrees. However, if you didn't remember that, you could do pi by 2 multiplied by 1 radian, which is 360 over 2 pi. The pi's cancel out. 360 over 2 is 180, 180 over 2 is 90, or if you type it into your calculator you will get 90. So either way you get 90 degrees, but it is handy to remember some very common radians, particularly pi, which is 180 degrees, pi by 2, which is 90 degrees, pi by 4 would be half of that again, so pi by 4 would be 45 degrees, and then obviously 2 pi being the whole circle. Let's have a look then at how we can go the other way, and how, if we've got degrees, how we can convert that into radians. So in this example, what is 75 degrees in radian? Well, remember, we know that 1 radian is equal to 57.3 degrees, which is not our accurate answer. Our accurate answer is to keep it as 360 over 2 pi, or 180 over pi. So when we know what 1 radian is, we can then work out what any number of radians are, or how many radians fit into so many degrees. So we know that 1 is 57.3 degrees, so 2 is going to be too big. It is going to be somewhere between 1 and 2. So we are expecting 75 degrees to give us an answer of 1 point something radians. What we need to do is work out how many of those radians fit into 75 degrees. So we need to do 75 divided by, this time, 360 over 2 pi. Now remember, to divide by a fraction you can actually flip and times. If you don't understand that or can't remember that, then have a look at my video on fractions. But for now we are going to go ahead and times by 2 pi over 360. So I flip the 360 over 2 pi and I'm timesing instead of dividing. So you type that into your calculator and that gives you an answer of 1.31 radians this time. And again, that is to 3 significant figures. And that makes sense. Again, we're sense checking the answer. 75 degrees is more than 1 but less than 2, so 1.31 sounds about right. So let's have a go at doing 225. So we do the same thing, knowing that this time we can times by 2 pi over 360. And if you type that into your calculator might give you the answer 5 pi by 4. If you have a scientific calculator. If not, it will give you the answer 3.93 radians. So in this case, unless told to do otherwise, I would leave my answer as 5 pi by 4. It is more accurate than actually working it out as a decimal and rounding it, because 5 pi by 4, if you remember our circle, we know that 180 degrees is pi radians, which is actually 4 pi by 4. So we know that we need another quarter of that. And it is easier to envisage 5 pi by 4 radians than actually 3.93 if you remember your common radians. If you remember that pi by 4 is 45 degrees, this is 180 plus 45 degrees. However, either answer is valid. The 5 pi by 4 is just more accurate. So as a quick recap, to convert from radians to degrees, so if you have an angle in radians and you want it to go back into degrees, you take your angle in radians and you multiply it by 360 over 2 pi. To go from degrees to radians, so this time we want it into radians, you take your degrees and multiply it by 2 pi over 360. So these ratios are the same, 360 to 2 pi. To remember which way round it goes, I find it's useful if you want it in degrees, the 360 goes on the top because that is the degrees. If you want your answer in radians, the 2 pi goes on the top because that is the radians. That is just how I remember it. It is better if you remember it in terms of how many radians there are in a circle. There are 2 pi, so you need to split the 360 into 2 pi parts to get 1 radian. And it is also very, very good to sense check your answer. Remember that you are expecting the degrees answer to be bigger than the radians answer because 1 radian is 57.3 degrees, and vice versa, you are expecting a radians answer to be smaller than a degrees answer. So if it goes the wrong way, then you've done your ratio the wrong way up. So check your understanding of radians and have a go at doing these conversions. So to convert to degrees, we need to multiply by 360 over 2 pi. The 360 goes on the top because we want our answer in degrees. So 1.92 multiplied by 360 over 2 pi. Type that into your calculator and you will get an answer of 110 degrees to 3 significant figures. Again, sense check it. We are expecting more degrees than radians. That makes sense. If you had accidentally done it the wrong way up and done 2 pi over 360 instead of 360 over 2 pi, your calculator would have given you an answer of 0.0335 degrees. That is clearly wrong. 0.0335 degrees is tiny, whereas we know that 1 radian is actually quite large. So that is clearly wrong. So your answer to this question, to 1A, was 110 degrees. I also want to point out that you need to be careful when typing this into your calculator. If you type in 1.92 times 360 divided by 2 pi, so if you use a divide sign rather than the fraction button, in some calculators this will work fine because your calculator will assume that because you've written the 2 pi together, it means that you want to divide everything by 2 pi. However, order of operations, or BIDMAS, BODMAS, PEMDAS, however you've learnt it, sometimes tells certain calculators to do something different. If we've got 1.92 times 360 divided by 2 pi, some calculators interpret that as a time sign being in between the 2 and the pi. Now, order of operations tells us that when we've got division and multiplications, we go through in order. So we'd multiply by 360, then divide by 2, and then times by pi. So rather than ending up dividing by 2 and pi, you're dividing by 2 and timesing by pi. Now, as far as I know, most calculators assume that because you've written it together, you meant to put it in brackets, but some don't. So to be sure that your calculator is going to do the right thing, either put the brackets in or use the fraction button. Just type it in as it is written here as a fraction, and that solves any potential mistakes. So let's have a look at number 1b. So this time again we are multiplying by 360 over 2 pi. And we can actually simplify this fraction down. The pi's cancel out. The 360 divided by 6 is the same as 60, and then 60 over 2 is the same as 30. So we end up with 5 times 30, which is 150 degrees. Again, you could have just typed it into your calculator and it would have given you that, but it is a good skill to be able to cancel down and work out the fractions. So number 2, to convert 2 radians when we already have degrees, we know that we need to multiply this time by 2 pi over 360 because we want an answer in radians, so the 2 pi, the radians, goes on the top. So 142 multiplied by 2 pi over 360, type that into your calculator and you will get 2.48 radians. 270, multiply that by 2 pi over 360. This one actually cancels down into a nice fraction, 3 pi by 2, because remember 270 degrees is actually 3/4 of a circle. Half a circle is pi, so we've got pi and half of pi, which is 3 pi by 2. You might have done that as a decimal, in which case you would have got 4.71 radians to 3 significant figures. So I hope that has helped you to understand what a radian is and how to convert between degrees and radians. Like I said, radians are actually a more useful measurement of angles, particularly when dealing with circles or circular motion, or when going on to do higher maths such as integration and differentiation. It is a very important unit of measurement as it gives a more direct link between the angle and the properties of the circle. So although you might be used to degrees and you know how to use degrees, and degrees are useful, they have their uses, radians do also have their uses and are very important to know. So good job, and I will see you again soon.